Welcome to a lesson with Dr. Powell. We're going to take a look at a very specific integral and see the various things that can happen sometimes. This is a trigonometric integral. Now, the technique that we're going to use is integration by parts and a couple other things too combined. Okay, so let's take a look at secant x and secant squared x. We multiply these together. Why did we do that? Because we actually know secant squared x is a derivative of something. And so that's a good start. And if you know something's a derivative of something, or how to take derivative of one thing or another, I mean, this is a good place to start. So integration by parts is a reliable option sometimes. But let's see how that works. The antiderivative of that would be tangent. And then derivative of that would be secant x tangent x. Now, hidden in this is actually a repetition of lines because of an identity. Tangent squared is equal to secant squared minus 1. So that means when we multiply this out, we actually have let's see, a plus and a minus. We have secant x tangent x minus the integral of just multiply secant times secant squared minus 1. Secant cubed x. And then we have, okay, so we keep the minus out there, so that's fine. So secant cubed x and secant minus secant x. Okay. All right. Now we can take this integral to both parts. We can have a dx there, and here that negative with that negative make it a positive like that. So that looks good. From another video, this right here is the natural log of absolute value secant x plus tangent x. And we could have put a plus c, but we could keep the plus c in here. However, may as well put a plus c, because see, this is the same thing as this on this side. So think of this as being like a, and this is being like a. If you add a to both sides, it'll get rid of over here, it'll double over there. So if you just divide everything by 2 over here, and we'd have secant x tangent x, and then we have a plus, and that is actually equal to the antiderivative. We just computed the antiderivative of secant cubed. Thanks for watching.